A real incredible responsibility as the chief medical officer of Ortho Laser to really make sure I understood this stuff. And I didn't take it lightly at all. And I've been over to Vicenza, Italy now twice to meet with the laser manufacturer as well as Professor Monica Monaci from the University of Florence, who's one of the world's leading authorities on cellular biology. I knew clinically that my patients were doing well, but I wanted to understand why. And so I felt compelled to try and learn as much as I could so that I'd be able to educate doctors that were interested in owning a franchise. The M8 laser has two wavelengths, 808 and 905, and those are super important to understand the depth of penetration that the laser will have. Depth of penetration is based on a few things: skin pigment, hemoglobin, as well as water content. So 808 to 905 is that perfect layer that allows the lasers to penetrate the tissues, get into the zone of where the pain and inflammation is from the typical conditions that we treat. That's in the infrared spectrum, so you can't see it. What's also really important with laser, especially a class 4 laser, and when you talk about classes of laser, it really means about the power of the laser. The peak power of the M8 laser is 75 watts, which puts it into a class 4 category. There are other class 4 lasers that are out there. However, they are a continuous amount of energy. What does that mean? It means that there's concern for the possibility of tissue heat energy getting too high. So what do they have to do? Well, they're handheld and they're moved, and they have to keep moving into the zone of where the inflammation is. So they can work and they can provide pain relief, especially with those correct wavelengths, but they require a technician to hold the wand throughout the entire treatment. So purely from a business model, it's much more difficult to be able to lase more people in that model. So it can be safe, it can be effective, but it requires more attention to detail. What's unique about the M8 laser and the patented technology of the M8 laser is that it's a pulsed energy. It goes on and off anywhere from 1,500 to 2,000 times a second. So what that does is you're sending photons, which is the energy, into the cells, but it's giving rest time for the cell to absorb that photon energy without creating heat energy. So you don't have to worry about skin necrosis, blisters, generating heat energy. So now you've got a robotic laser. You can set the laser into the zone where it moves across the field, sending the laser energy exactly where you want it to, and your laser technician can be in another room setting up the next patient. The basic science of laser is actually exceptionally well documented. If you take laser to a cell, and then the cell is in that field of laser, it does stuff. And the stuff that is done can be measured. So everybody that has lasers always talks about increased amount of ATP generated by the mitochondria. So cytochrome oxidase, which is an enzyme within the mitochondria that's part of the Krebs cycle that generates energy for a cell, is stimulated by light. It's a photochrome. So there is a protein, which is the enzyme, that gets excited by the photons if they're in the right wavelength of energy. So yes, ATP is increased. You can absolutely measure that. It is an assay. You can generate and tell, you can show me the exact increase in amount of ATP by using a laser such as the M8 laser. But it's not just that. ATP binding proteins are also increased into the area as well. There is a gentle increase in temperature of about 1 to 1.5 degrees to the local area in which the cells are in. This creates vasodilation to the area. It helps to bring in blood flow. There's clear evidence that it can bring in fibroblastic ingrowth to the area as well. All of these things can be measured within a lab through an assay. So for example, a fibroblast scratch test. It's a classic thing that's done by cellular biologists. Put it on a petri dish, put your fibroblast cell culture in, scratch it, and then there's a gap. If you put it under laser, those fibroblasts grow back together quite quickly, much more quickly than if you didn't use laser alone. So again, there is study after study after study for basic science that shows how laser works at the cellular level. And what I like to say for our franchisees as we get rolling here is that we're going to prove this by doing the studies ourselves. And I'm very excited for the opportunity for like-minded, entrepreneurial, innovative ortho laser franchisees to jump on board so we can start doing some of these studies so we can prove to the world, at least the United States world, that laser is a great alternative option for the treatment of many of these acute and chronic orthopedic conditions.